Okay, well, good evening, everybody. Hi. Thank you all for coming. Hope you all had a great summer. And, welcome to IRMA's first meeting of the next year. A few bits of housekeeping before the talk gets started. I'm told the fire exit is through this door here. I'm not expecting a drill, so any fire alarms will be real. There'll be coffee and food afterwards and supply, so please do stick around for some networking and chatting about the talk. We also have a LinkedIn group, so please do join the LinkedIn group if you're not already members. Join in the conversation from there. Tonight's event is being recorded. A link will be sent around in a few days by email, and this will be available to watch on Panopto. So all of the talks are recorded and available later to watch again. I've got an attendance list, which everybody could please sign that. And in a few days, a feedback form will come around by email. If you could all give feedback, that would be brilliant, so that we know what you think of the talks, and what ideas you might have for future talks. So, but just one last thing before I introduce Bill, tonight's speaker. A certain member of IRMA's committee has been given a very distinguished award recently. The John Ivinson Award. He's trying to look invisible at the moment. And this is in recognition of his truly exceptional voluntary service across a wide range of the institution's activity. And this spans, so he tells me, 30 years. So this has been awarded to John Mitchell. John, would you like to stand up, please? He's right at the back there. But I think before we begin, and tonight, Bill Harpley has come to talk to us about connected autonomous vehicles. So I'm going to hand over to Bill for this very topical, very timely subject, and hope you can dispel some things on this subject, which I find quite
myths.
Urban myths.
Okay, I'll do my best.
Okay, thanks very much.
Nice. Good evening, everyone. I'm Bill Harpley. Title of tonight's talk is Connected Driverless Vehicles, the Road to Safe and Secure Mobility, ? Okay. I think we'll probably begin with a question mark, and we will probably end with a question mark. There's a lot of unanswered questions about this topic. That's me. Can you see in the back with the lights and all that? Okay, good. Okay. I've got an optician's appointment on Friday. I can see this fine from the front, so probably didn't see it in the back. Basically, I run Astius Technology, which is an IoT consultancy in Brighton. I also run the Bright IoT members, IoT forum group, and that's got 800 odd members now, so it's grown 100 since May. Okay, I also run, I'm also on the organising self-driving cars and autonomous vehicles meeting. Okay, what we're going to look at in this presentation, essentially, we're going to ask the question, we're going to try and define what do we mean by a driverless car or a connected car. We're going to look at some of the kind of technologies behind it, why they're vulnerable, and we're going to look at some of why actually automotive security is actually very difficult. We're going to look at the current state of the art, and we're going to look forward to some possible remedies in the future. Okay, the great connected car opportunity. Right, I thought we'd start with have a bit of fun to begin with a poll. Back in June, the Transport Research Laboratory joined forces with Royal Holloway, a security group there, and they did a poll, and they asked two questions. The first question was, driverless cars are a good idea. That's the first proposition they put to people. And the second proposition was, I can trust a driverless vehicle. And I thought it'd be interesting if we opened the meeting by asking these two questions. So these are the two questions. Driverless cars are a good idea. I can trust a driverless vehicle. So with regard to proposition A, driverless cars are a good idea. Raise your hand if you think they are. Oh, about 80% or something like that. That's quite good. That's interesting result. Proposition B, I can trust a driverless vehicle. Raise your hand if you agree with that proposition.
It depends on the timescale.
Well, talking about the poll that was done in June, because I thought it would be interesting.
Well, we're talking about driverless vehicles on the public road or on the track.
That's an interesting question. I think that they were looking forward and they were sort of looking in general terms as to what the public attitude is. Right? Okay, that's the poll. Anyway, the results of their poll, it's quite similar to ours actually. That should be a typo. I'll have to fix that. Driverless cars are a good idea. 81% broadly agreed, 1% broadly disagreed, and 18% were undecided or slightly disagreed. Okay. Proposition B, I can trust a driverless vehicle. 78% broadly agreed, 3% broadly disagreed, and about 90% undecided or slightly disagreed. Okay, so the results aren't that different from what we've done here this evening. That's from a poll of about 180 people. It's not very scientific, but it's kind of interesting, to do that. We'll revisit this poll at the end of the session, and you've had another chance to vote. Okay, reasons to be cheerful. It's not all doom and gloom and bad news. There are numerous benefits which are claimed by cheerleaders for driverless cars. The first one, of course, economic benefits. PwC published their annual Connected Cars report for 2016. It claimed that the connected vehicle market was set to be worth £120 billion by 2022. So there's some big sums of money involved. And that, of course, will create a lot of new jobs and create prosperity. At least that's the theory. Safer journeys, according to the World Health Organization, back in 2015, there were some 1.25 million global traffic deaths, and that's been a similar kind of figure for several years now. The goal of automatic driving would be to reduce this figure to zero. How attainable is that? I don't know. It would also reduce the economic cost of accidents, because of course people have accidents, they're hospitalised, economic output suffers, so on. The other one, of course, is greater productivity. So the average UK driver, worker, spends about 124 hours stuck in traffic jams each year. I don't know whether it registers with you or you spend more time than that or less, I don't know. That's a kind of figure you'll find on the internet. Automated driving would create a less stressful experience, enable them to do more work on their... Right, so instead of having a pleasant commute to work, you can actually do some work. That's the theory. And then, of course, we've had this new emerging idea of mobility as a service, whereby you don't own a car. You can do ride sharing or driverless taxis. They just come to your house, pick you up, right? And that removes the need for you to own a car. That's the theory. And it's claimed that would create a lot of social and environmental benefits. How realistic are these? Only time will tell. Next, connected car. Oh, you can't see that at the back anyway. This is a beautiful poster. Do study it when you get the slides. It's from a lady by Liz Slocum Jensen, and it's really, really brilliant. It shows all the kind of apps that you can get. What I'd like to bring to your attention, though, look at all these apps on here. Two relate to security. Okay. Does that come as a surprise to you? No? Okay, the roadmap to a driverless future. There's an organisation called the Society of Automotive Engineers in the United States, but they have global membership. They're very active in creating standards. Again, you probably can't see this very well, but don't worry, I'm going to explain it in more detail on the slides. I just bring this to your attention. It's standard is called SAE J3016, and it's kind of like the benchmark industry standard that everybody uses now these days for defining different categories of automation for vehicles. The main takeaway here, I think, onto this slide, is that there are actually 6 levels, starting at 0 through to 5. Okay, and each of these, you get progressively more automation as you go along. Levels 0 to 3, that's these. They're commonly referred to as ADAS, that's Advanced Driver Assistance Schemes. When you get into 4 and 5, you're getting more towards a driverless car. So it's not just driver assistance, it's a car doing the driving for you. Okay, hopefully you can see this in the back. This is kind of like more of a summary. Level 0 is driver only. That's like a conventional vehicle with no kind of electronic controls or anything. The driver works it all just. You haven't seen one of those on the road for quite some time, at least not new ones. Level 1 is assisted driving. That's when the driver receives support for specialised tasks, such as, for example, parking in a narrow space. Level 2 is partial automation. Now, this is where the driver receives support for coping with predefined scenarios, such as traffic congestion warnings and avoidance. And you can start to see we're going from the very specific, like parking in narrow space, we go towards the more general kind of scenarios here, with more automation. Level 3 is conditional automation. Now, this is where the driver can relinquish control of the vehicle for specific tasks, but must be ready to resume control at short notice. In fact, for example, motorway auto crews, you might have a car that does that for you, and that would be classed as level 3. Level 4 is where things start to get really interesting. Significant automation. This is where the majority of driving tasks may be automated, but the driver must be ready to take control if needed. Such as, for example, urban driving, very busy traffic. Now, this is very interesting because, of course, these two, they involve handovers. They involve some kind of manual handovers. Okay, I'll have more to say about that in a moment. Level 5 is complete automation. That's 100% automation of the journey. Probably the best example of that is Google Car, or Waymo, as they're called these days. Now, this kind of manual handover business is actually quite a hot topic in automotive service. So there are essentially 2 strategies in the automotive sector. There are people who want to take an evolution path to full automation, which requires the driver to hand over up to level 4 capability. Examples of that would be Volvo and Tesla. Okay, they're prominent. Toyota, most vendors are going that route. But there are other people who are saying safe and reliable handover is just much too difficult to achieve in practice. You might take 10 seconds or maybe even longer. And if you've got a critical situation that needs to be dealt with, then it has its limits. So some people say, well, let's not bother with that. Let's go straight, invest all our resources in developing a fully autonomous driverless vehicle. And that's the approach by people such as Google Car or Waymo, as I said. So, and the other thing to note about this roadmap is you look at the SAE roadmap and you think, and it's kind of nice progression of automation levels, but if you think about it a little more seriously, at any given point in time in the future, it's going to be a bit of a mix with different types of cars on the road. Some might still be manual, some might be semi-automated, and you might start to get a few automated ones in the mix. So, a possible recipe for chaos, crime, accidents, and novel security exploits? Quite possibly. Right, today we're going to just talk about cars. That's more out of convenience than anything, but I should point out that pretty much everything we say this evening also applies to taxis. There's an Uber taxi there. There's Future Intelligence. That's trucking. That's actually an example of platooning, which is being proposed on the roads, I think, later this year in the UK, and also buses. So these kind of trials are going on in many parts of the world at the moment. Okay, so we're going to look at the basic building blocks. Before we can understand the security aspects of it, we need to have a little bit of idea of what goes on under the bonnet, so to speak. So, car hacking's been in the news. You've probably read quite a few stories about it. I'm not going to bore you with them anymore tonight. We're just going to say, and this is the famous Jeep hack from 2015. in which Cherokee Jeep was remotely hijacked and driven off the road. And that, if I remember correctly, the hack was via the DAB radio. Correctly. So, and then they got access to the steering system, and it was driven off the road. Right, can't see that on the back either. It's fine. Well, I'll tell you what, it looks a very busy slide, but actually it's much simpler than it looks. You just look at a piece at a time. Every car, new car, has lots of sensors these days. For example, radar, LiDAR, temperature, acceleration, cameras for image processing, things such as pressure, ultrasound. So it's got lots of these sensors. And also, on the right, the little green boxes, these are actuators. And in cars, they're electrical and hydraulic. You know, the actuators, you think of them like switches or where pressure is applied. Okay? Okay, so they make something happen. Okay, so the sensors detect something, the actuators make something happen. Okay? Okay, now in this next set of boxes here, there's communication buses. Since, of course, all of the sensors and the actuators, they need to communicate with their controllers, and they're done over buses. Some of these are pretty much most of these are specific to automotive, except Ethernet. That's not very common. It's starting to creep in a few applications, but Ethernet, not very common. The most common one of these is the CAN bus. This was developed by Bosch in the late 1980s. It's now an ISO standard. I can't remember what the number is off the top of my head. Very, very common, very, very common. And it's probably one of the buses that people are most concerned about, because it's actually a fairly open kind of bus standard. And that's used for things like safety critical aspects, such as the drivetrain and steering and so on. There's the LIN bus. That's a very kind of low speed, low bandwidth bus that's used for non-critical things like electric windows, okay, things like that. FlexRay, again, that's another high-speed bus, which is kind of creeping. Some people are using again for safety critical features. That's kind of creeping. There's a bus called MOST, which is multimedia. So that's nothing to do with the engine or the body or the chassis. That's all to do with the multimedia side of things. And of course, Ethernet I mentioned. Now, the key subsystems, what the sensors and the buses all are kind of connected to are these subsystems. These are the powertrain, the chassis, the body, and also the infotainment. Again, infotainment is the most bus. That's the word I'm looking for. And I'll say more about these slide 2 times. Then, under the bonnet, you've got specialised control units. Very common ones are ECUs. These are called ECUs, electronic control units. And one car might have more than 100 of these. You know, the number seems to be multiplied like rabbits in modern cars. Many cars also have a telematics control unit, which provides a gateway connection to the outside world via a mobile network or Wi-Fi. Okay, and down here is the arch villain of the piece, as we discussed. It's the OBD interface. So if you buy a car, somewhere under the dashboard, hidden away under the dashboard or somewhere, there will be a connector. You can't really see it here. Even I can't see it very well from here. But there is a port. It's typically hidden away under the dashboard or somewhere. And that's normally used for diagnostics at the garage. Okay, but a third market, a kind of aftermarket is developed for third-party devices which plug into it. And there are all sorts of things that you can do with this, like Raspberry Pi projects, so you can actually monitor what's on your CAN bus and so on. But that connects to the CAN bus. This is why people are so concerned. Okay, this is a nice little diagram. I was going to draw one myself to write out this. This is from NASA, that's the EU security body. They've got a very nice document called Good Practices on the Security and Resilience of Smart Cars. This is, I cribbed this one to save me too. So what you've got here is the powertrain, okay? So you've got the powertrain, and that gives you examples there, such as transmission control and engine control. Down here you've got body control, so you've got things like climate control internally within the car, the instruments on the dashboard, and also things like door locking. So that's what the body control does. Up here you've got the chassis. chassis control, and that does things like, of course, steering, things like airbag safety and braking. And down here you've got your infotainment system, which uses this MOST bus. Okay, and that can say you plug in your phone, navigation, sat nav, also things like music and video. So what do these ECU looks like? Well, this is just one example. Okay, they're all similar kind of form factor, they're all pretty small. And it's kind of like a generic term for these buses. And like I say, you might have 100 tucked away in your new car. So examples of the kind of functions that these would provide is things like parking assistance, brake-by-wire collision avoidance, automatic windscreen wipers, cruise control, and it does this all by getting the feedback from the sensors over the different buses and also controlling the actuators. And this is what they do. There's one down the bottom which is slightly hidden for some reason. So let's just have a quick look at what this looks like. This is an example of a CAN bus layout. Essentially, you've got your dashboard, so you've got all your information coming to your dashboard, typically. So the driver can see exactly what's going on in terms of like speed, acceleration, and so on. And you've got your CAN bus here. That will control things like power door, occupant detection, electric park brakes, lane assist, airbag control, ABS, brakes, transmission control, engine control. So these are all quite critical things. And if the CAN bus is compromised in any way, then that could put the safety of the vehicle and its occupants at risk, and quite possibly other road users as well, people going in the opposite direction. So this is serious stuff. This is an example of a TCU, telematics control unit. This one's from just an example from a company called Ficosa. They're quite common in the automotive industry. Again, it's able to provide things like security, safety, and entertainment applications. The capabilities vary slightly according to which model you use, but in this one, you can see it's Linux-based. Okay. 3G and 4G connectivity enabled, Wi-Fi hotspot connection. So if you're driving through a free Wi-Fi hotspot, you can use it. eCall enabled. eCall is something that's mandated to be introduced, I think, next year. And what it means is that if you're involved in an accident, the car will automatically phone the emergency services, let them know that you've been in an accident. Okay, so that's something that's starting to come in. GNSS, that's things like GPS, Galileo. And this particular model is rather clever because it's able to detect if you've had a crash and automatically trigger the airbag. Yeah, they don't all do that, but like I say, there are some different features in different models. It can support up to 6 CAN bus connections and also Ethernet. Okay, so that gives you some idea of how popular Ethernet is relative to CAN bus. 6 CAN bus connections, 1 Ethernet connection. Now, this is the arch villain of the piece. This is the OBD standard, 2 standard. What it means is OBD is onboard diagnostics, and these have been compulsory in all new cars since I think 2003, if I remember correctly, about 15 years. And like I say, if you've got a car, you'll have one of these tucked away. You might even be aware of this then. Now, the architecture of these is quite interesting because, of course, you've got your ECUs here, the electronic control units. They connect into a port, which in turn connects into and of course, aftermarket devices plug into the port. Now, most of the time, it's quite legitimate, but it can be abused. There's a lot of concern about this, particularly if someone plugs in something that's malicious. It could get in various ways. For example, you can go along to take your car onto a garage. It might be that the equipment, the diagnostic equipment, has been infected with malware, for example. There are lots of scenarios as to how that could really screw up your engine. Okay, so we've looked at smart cars, but really we need to look at the bigger picture and think in terms of smart traffic. Okay, so we think more broadly in terms of connected cars. Okay, so let's see how we get there. This is something that's really been trialled on a small scale For example, in the United States, University of Michigan have got a special track called M2M, something like that. I can't remember. But anyway, these have been tried. These have been kind of tried on a small scale. Nobody's scaled this up yet. You can't actually buy a car that's got these kind of capability ready. But it has been mandated in the United States that new cars will have this fitted in the very near future. I can't remember the exact date. But essentially, what you have here is you've got two cars going in the same direction. One might use radar for hazard detection. They're sending status messages to each other, the cars. And if this car, for example, detects a hazard, for example, with a car front broken down or something, then it sends a message to the oncoming car or the car behind. Okay? So these use a standard called communication links, or IEEE 802.11p. Should give you a clue that it's a variant of Wi-Fi. The range, if I remember correctly, is about 200 meters. It's not very big, but it's enough to do this kind of short-range messaging. The kind of things you might get are things like messages like traffic jam ahead, I just put the brakes on, ice on the road ahead. So these kind of hazard warnings. Right, okay, must be secure. Because, again, the other thing that people are very concerned about is, of course, issues of security and also of privacy, right? Because one thing I haven't mentioned is this whole kind of technology. There are huge implications for personal privacy and mass surveillance, and it's a talk in itself. We're not going to spend much time on that. Just bear that in mind. Look at that one. Vehicle to infrastructure. Right. This is things like talking traffic cones and things like this. So again, this is where it's not just cars talking to each other. It's also infrastructure. So you might have infrastructure like traffic lights or traffic cones if this works, or car parks advertising how many free bays they've got left. They're all kind of talking to each other and also talking to the cars as well. These are called roadside units, typically. And the kind of message you might get are things like road ahead closed, turn left at junction, roadworks ahead, space available in Broad Street car park. That's the kind of thing. Get there. Now we get onto vehicle-to-person networks. Now, right, okay. Now, again, these are all IEEE 802.11p links. And they could be, for example, these kind of transponders could be carried by pedestrians and joggers, horse users. I think this is something that has been, I think it's the British Equestrian Society or something like that has been looking into this. Since, of course, if you've got a silent electric car which is autonomous, sneaking up behind the horse probably is a good idea. Certainly that's the horse anyway. And also people like cyclists, scooter riders and two-wheel transport. We also carry these types of transponders. Yeah. And again, so the messages are going to the car, and quite possibly, even if there's any benefit at all, you need to also get messages from the car as well. Right, there's one variant here, is of course the mobile cellular industry. They see this as a potentially big market, and so they want a slice of the pie too. So they've got their own solution, which they call BLTE. So essentially it's like 4G networks. So instead of cars talking to each other like this, they talk to a phone mast, okay? Talk to the nearest cellular mast, and they get their messages that way. So it's not peer-to-peer, it's more of a centralised structure. So you get the idea of that. So this is developed by 3GPP, that's the body that's responsible for developing specifications for the mobile cellular industry. But this has been trialled in a few places on a small scale, like Australia, Vodafone did one trial. Essentially, it aims to provide all the functions of V2V, V2P, and V2I. So the whole thing. What else can I tell you about it? Oh yeah, there are some problems, of course, in that it's parts of the UK are like a 4G desert. You can't get a connection. So there are problems with cellular coverage, and also issues such as you need a SIM, obviously, in your car, but which SIM do you have? Do you have multiple connections to, if you want connections to multiple carriers? It gets complicated. Okay, these are a few just applications of vehicle to everything. First of all, is urban traffic management. So the idea there is at junctions, for example, you can have improved traffic flows. Vehicle tuning, I mentioned, which will be trialled later in the UK in December, I think it's been mentioned. Okay, and the idea behind vehicle tuning is that trucks and other vehicles could be packed closely together, and you'll have a lead vehicle, and the others just play follow my leader. This has been quite extensively trialled, for example, in the United States and Germany already. Hazard detection and warning, again, you might have a car who's detected black ice on the road, and it encounters a very dangerous road surface, and again, it can send out messages to track the traffic in the area. Now, of course, all of these depend on the integrity of the wireless links. Okay, so in terms of availability and security. One thing I should perhaps mention, to go back to one of these, all these kind of scenarios, they assume that the cars, the vehicles, are able to authenticate each other. So you would need a certificate infrastructure. It's very complicated. There's kind of work in progress on that for example, Car Consortium and EPSI. They're kind of working on that, but we're a few years away from having anything like that. So we've looked at kind of like components and also the basic ideas of how you might build an infrastructure, a complete working infrastructure for cars, vehicles to interact with each other. So what are the key challenges? Automotive security. Right, challenge number one has to be supply chain. You've got a global supply chain in many cases with components coming from many different countries, and typically manufacturers. That's the prime manufacturer, such as Volvo, for example. They would be using just-in-time delivery processes. So how do you actually ensure the provenance of these, integrity of these is an open question at the moment. And these are typically structured. You have a tier 1 supplier, who in turn subcontracts out to tier 2 suppliers. You have a prime manufacturer there. So again, that would be something like Volvo, Volkswagen, Audi, something like that. Then you have the aftermarket, which I mentioned earlier about these OBD2 diagnostics, and also these kind of value-added dongles which you can plug in. I'm not an expert on those, but you can see that this is like a major headache in terms of actually, first of all, there's a lot of fake components out there. Millions of pounds of fake components are on the market, and how you actually ensure these from a security standpoint of view is something that needs to be solved, and this is something a lot of people are thinking about. Next, just thinking about just one car on its own, it's a huge attack surface. Here you've got external interfaces for Wi-Fi, 3G, 4G, 802.11p. We've got the OBD2 port. Up here we've got you've got the infotainment subsystem. You've got body control, powertrain control, chassis control, and of course communications control through telematics unit. And then of course you might have a smartphone connected via Bluetooth, for example, into the console of the car, and that could be accessing cloud-based services. We all want that cloud-based services, but again, you can have things like data theft, identity theft, insecure APIs, denial of service. It's hacker's paradise. Just one car on its own, hacker's paradise. Now, if you multiply that by the number of cars on the road, and then you think, well, what happens if we start connecting them all up? And then you have a really big problem on your hands. So challenge number 3 is the sheer complexity of code. The volume of lines of code in a typical car these days is probably well over 100 million. Now, I think something like Airbus has got about 5 million. That's for an Airbus plane, about 5 or 6 million. So it's a lot of code. Okay, this is an example that came out earlier this year. It's the Ford F-150 smart pickup truck. 150 million lines of software code. It's not even fully autonomous. Okay, not even fully autonomous. Again, you've got numerous points of attack. And sheer complexity. How do you test and debug 150 million lines of code? Yeah. Now, there's a lot of research going on to that, obviously, but we're not there yet. Next, challenge number 4. You've got a tale of two cultures. Going back many years, the automotive industry has developed a really strong culture for safety and reliability. And what you've had in recent years is you've had some kind of new kids on the block, so to speak, people like Google and Apple, and they want a slice of the pie. Okay? So you're getting a lot of new players who come from the information industry background. Okay? So you're getting a bit of a culture clash there. So in general, the automotive culture, their key values are safety and reliability. Okay? They have very long product development cycles. It can take 5 or 6 years to develop a new model car. They're very long product lifetimes. Some cars on the road for like 15, 20 years. So their focus is kind of like hardware, quote unquote. I also mean like mechanical as well as electronic. Okay, and these are the kind of traditional auto players in the market, people like Ford, Mercedes, Toyota, Audi, Chrysler, people like that. Right, now on the other side of the coin, move over here, is you've got the information industry has a very different culture. It brings with it values of user experience and security. Okay, security isn't perfect, but it's a lot better than what you find in the automotive industry. And they, by contrast, have rapid product development cycles, relatively short product lifetimes, and they have a strong focus on software. Okay. So these kind of players are coming now. People like Google, Apple, Nvidia with GPUs under the bonnet. Yes. Samsung, Microsoft, Intel. They all want a slice of this growing pie. And what you're heading to, in my personal opinion, is over the next maybe 15, 20 years, these two cultures will merge into what I call the informative industry. Okay, so you won't have an automotive industry, or you'll have something more akin to an informative industry. Oh, okay. Now, security researchers have naturally cast a keen eye over the kind of practices that they find in the automotive industry. And there are a lot of shortcomings. I'll just read some out for you. This is by no means a complete list, to just give you an idea. First of all, there's a lack of security by design and privacy by design. Okay, they really just don't do it to begin with this one, I think. Weak or non-existent authentication or authorization through components. Okay. Right. Lack of shared technical standards across the industry leads to some suppliers using glue code. Now, what do I mean by that? If you think back to that earlier diagram of the supply chain, we have tier 1 suppliers, tier 2 suppliers, and a prime manufacturer. If for example, tier 2 manufacturer makes a change to one of their components, then it might not work with tier 1, so then dream up some glue code, right, to make it work. And then this can propagate down the line in many different ways, and the cumulative effect of the glue code can be to weaken security, because of course it's not really documented in any one place. What else have we got? Yeah, the other thing is, even where the automotive industry is starting to take the issue seriously, security, but even then they have their own, different companies have their own individual approaches to it, so it's a very kind of fragmented approach to developing security within the automotive sector. Automotive vendors are slow to release security patches. Historically, that's been the case. They are getting better at it. Tesla now has over-the-air updates, and that's the way to go. definitely. The rest of the time, you might need to recall a car. You might have to call thousands of cars, hundreds of thousands of cars, quite possibly, just to patch them at a garage. Okay? So that's not very efficient. So over the air is definitely the way to go. But I think Tesla's the only one that really does it well at the moment. Right, and also, again, thinking back to this long supply chain, long global supply chain, there's no really clear standard for product liability in terms of security. Okay, so there are standards about product liability in terms of physical products, but security and whose responsibility it is not clear at all. Finally, design and development practices fail to integrate security and functional safety. And we'll see some examples of that later. So I can't be big long in this, but I think that's enough to be going on with. Okay, now what do I mean by safety versus security? Now you might think adding more security features would be a good idea, but it can lead to conflicts if you don't have a good process. And this is something that the automotive industry is wrestling with at the moment. Example number one would be a safety engineer who wishes to enable the debug on a microcontroller to do a RAM dump, okay, for safety reasons, to inspect the code. But the security engineer says, no, you mustn't do that. You must not enable debug. Example number two would be a security engineer wishes to add firewalls and authentication to safety critical components in order to improve security. But the safety engineer comes along and says, no, you mustn't do that. That could that'll add latency and could cause unwanted effects and perhaps cause issues of safety. So, if without a good process to resolve these issues, they end up like pointing fingers at each other. So, conflicts at this time really can only be resolved, I should say, through dialogue and designing better. Word missing there. Designing better processes. Okay. Next, we're going to look at the current state of the art. A quick tour of the current state of the art, and we'll see where it kind of falls short. This is the biggie. This is it's an ISO standard. It's been around since the 90s. It's ISO 26262, and it's concerned with functional safety. Or in other words, it does what it says on the tin, and it does so in a safe and predictable manner. It's an international system for functional safety, electronic and electrical vehicle systems in vehicles. It's not primarily concerned with security issues. It's concerned with, for example, corruption of data on the bus, but that can occur for kind of electrical failures, not necessarily people hacking into it. It doesn't really cover the hacking aspects. This is very widely used throughout the motor industry. So it aims to address possible hazards caused by malfunctioning behaviour of electronic and electrical systems. As I mentioned, it's not directly concerned with matters of security. MISRA C. Anyone familiar with MISRA 3? Come across that? Oh, okay. MISRA C is a set of software development guidelines for C and C+ programming language. C and C+ are widely used, but they do have a few well-known shortcomings. For example, potential for buffer overflows, which can be exploited for security reasons. It was first developed in 1998 by MISRA, that's the Motor Industry Software Reliability Association. It's been taken up outside the motor industry and it's widely used in, for example, aviation and in the medical equipment sector as well. So it aims to reduce the number of bugs, produce more good quality software. Right, I think I've covered that one. AutoSAR is another standard which has been around for a while. And again, the aim for this is, again, to improve the overall kind of, essentially to improve software quality and also to create components which are portable, software components which are portable across different vendors' ECUs. That's the idea. So it defines a methodology and a software architecture for automotive ECUs. And here's the big one. In version 4.2, which is the latest, the specifications have been expanded to consider evolving security landscape for connected vehicles. That includes things like memory protection, includes cryptographic services, end-to-end message protection. But prior to 4.2, going back a million years, there was nothing. So they're starting to address this issue. And of course, use of a common software platform, such as AutoSAR, may help to improve security in the long run, since of course people can build a lot of expertise on a common platform. That's also true for hackers, of course. But, there's a scheme called Euro NCAP. What this is a website you can look at, and it gives safety ratings of different cars. For example, here's a Ford Fiesta, that's a 5-star safety rating. Jeep Compass, 5-star. Mazda CX-5, 5-star again. They don't all get 5-star ratings, by the way. That's quite interesting. So there's been some kind of talk in the background of developing a similar system for cybersecurity of cars. It's something you will probably see at some point in the future. At the moment, it's just cocktail party chatter. Right. Okay. Something called common criteria you might have come across in your security travels. Essentially, products can be evaluated as to how effective they are at withstanding hackers. In a nutshell, that's really what it's about. And this has developed these ideas have been around for a long time. In the 1990s, things like the Orange base, trusted computer base. Now it's evolved into a more international standard. It's a merger of a lot of different standards. It's now an ISO 7. And what this does, it permits the product to be certified to a specific evaluation assurance level. And these levels start at 0, they go through to 7, and they become increasingly difficult to crack into. Okay, so for a level 1, you wouldn't need much time, you wouldn't need all that much time or resources to hack into it. That might not matter, depending on what kind of product it is. So the evaluation, again, by the time you get to level 7, it's very, very difficult. I don't know that there are any level 7 products out there. There probably are, but I can't think of them. The evaluations are conducted by accredited laboratories, so these are independent evaluations. Right. So these are the kind of components, some of the components which you find in the automotive industry. They are judged against this. They are these kind of criteria. I'll give one example. Many common operating systems have been evaluated up to an assurance level of 4. For example, Red Hat server, Microsoft Windows server. Give you some idea about how difficult they are. This is one of the most important things to have come out in recent years. It's our old friend again, the Society of Automotive Engineers. Different standard. This is J3061. And it's called the Cyber Security Guidebook for Cyber Physical Vehicle Systems. It was published just over a year ago, in June 2016. It defines a complete lifecycle process, which is what the industry badly needs. Framework go from the initial concept through to production, operation, service, and decommissioning. It provides information on some common tools and methods which are used for design, verification, and validation of cyber physical system security. And the other ambition is that it really provides a kind of foundation, kind of base for further work in the field. Okay. Right, back again to our old friend, the connected vehicle. These usually, as I mentioned, they use IEEE 802.11p standard. And the security is defined by another IEEE standard, which is 1609, the security. That defines a set of standards for wireless vehicular access, or WAVE as it's often abbreviated to. That supports vehicle to everything data, exchange between high-speed vehicles, between vehicles and the roadside infrastructure. As I mentioned, of course, to deploy this on a large scale, you would need a certificate structure. That's kind of in the works. Current regulations which impact connected cars and smart cars, any kind of cars with this kind of connection, are, of course, the GDPR, which is coming in May of next year, that really strengthens individual privacy rights. So you've got to be really on the ball with that one. And as I mentioned, privacy rights are a really hot topic for connected cars. Really hot topic. And the other one down here is the Network and Information Security Directive. That's a set of EU-wide rules and regulations regarding cyber security. And it puts the onus on operators and owners of critical infrastructure to make sure that their services which they provide are secure. Oh, I'm not going to read all this. Right, don't worry, don't worry. So what's the government been doing about this? Interesting. Back in August, the government issued what it calls the Principles of Cyber Security for connected and automated vehicles. It's on a website. I can't remember which one. I can give you a link later. And essentially, it sets out 8 principles for essentially governance and kind of standards what organisations need to do. For example, number 2 is security risks are assessed and managed appropriately and proportionally, including their specific to the supply chain. So it kind of touches what I mentioned earlier. Let's have a look at number 7. Storage and transmission of data is secure and controlled. 8 systems designed to be resilient to attacks. That kind of thing. This has been criticised. This has been criticised because it's nothing new there really, and it's been criticised being almost a kind of cut and paste job from other documents which you can find on the internet. So it has come into some stick. They're very late with this, by the way. In the United States, organisations such as the National Highway Transport Safety Authority, they've had these kind of guidelines in force for quite some time. Highway to the future. So the current state of the art at the moment is it's got a lot of holes in it. It's not a bit flaky, to put it mildly. So what can we do to improve things? Well, in the pipeline is another ISO standard. It's the 21434, and nobody knows quite the exact contents of this, but it's expected it will do things like define clear processes. Anyway, the full title is ISO 21434, Road Vehicles Cyber Security Engineering. That should be out sometime in 2018, and there's a lot of people hopes are kind of riding high on that. My expectations when that comes out. And it'll probably build on a lot of existing work that's been done, such as the previous SAE cybersecurity, automated cybersecurity term. As I mentioned several times, what's lacking is some kind of unified development process. Otherwise, you get finger pointing and not time wasted. So, when we get this kind of thing, and it'll happen one day, I don't know when, it will really be a crucial milestone which to move forward. So here you've got functional safety and security design, and the different stages of that happen in tandem. Okay, so you don't go barnstorming ahead to stage 2 until you've finished this one. So roughly, I'll probably can't read them, so I'll read them for you. This one's hazard analysis and risk assessment. That needs to be synchronized with threat analysis and risk assessment. Definition of safety requirements, that needs to be synchronized with definition of security model requirements. Okay, this one, system design, that needs to be synchronized with defense in depth system design. And the last one, systems verification and validation, that needs to be synchronized with security verification and validation. Okay, so you have a unified process. We're a long way off that. Hopefully, you might see something like that in the forthcoming ISO. This is just kind of like a guess at what it might look like. It's not. Don't take it too seriously. It's just indicative rather than concrete. Right now, the automotive industry has traditionally had quite a closed mindset. But this has given them the kind of incidents like the Jeep and so on, given them a bit of a wake-up call, a bit of a shock over the last couple of years. They're starting to open up and collaborate more with people outside the automotive industry. So now you can see that there is this growing spirit of openness, collaboration between automotive and non-automotive actors. Some of the kind of players in the security side of things are an organisation called FASTA. There's the 5G Automotive Association, which is again like the cellular operators who want a slice of the pie. There's Car-to-Car Consortium, which is a kind of EU-based organisation. And there's Auto ISAC, and that's a North American-based organisation. And what they do is information sharing. So they pool knowledge about security threats. Okay, so people will join up and they can actually share knowledge about any security threats they get. And of course, there's INISA, they have a CarSec expert group, okay, online, and they have some meetings once or twice a year as well. Okay, so what does this mean, all this openness and collaboration? Well, now there's lots of regular conferences now going on all around the world on the subject of automotive cyber security. They've really kind of mushroomed over the last couple of years. Industry consortia, these are the kinds which I mentioned. Sharing of expertise, again, that would be something like Auto ISAC. There's in some operators, some vendors in the United States, have started to operate bug bounty programs, which was completely unheard of a couple of years ago in the sector. And they've started to organise things like white hat hackathons. So they invited the white hat hackers in to hack their ECUs and their TCUs and generally try and break them. Okay. Next, roles for blockchain. Now, blockchain has really taken off very considerably over the last few years, as you know, mainly in fintech, but now people are looking outside fintech. My personal view about blockchain is the most interesting applications lie outside fintech. Okay? And you're starting to see this in the automotive sector, and there's quite interesting startups in this space. And the kind of things which they are doing to improve security would be to track and verify automotive parts across the supply chain. That includes spare parts and warranty repairs. Again, it goes back to this really long supply chain. How do you keep tabs on all that? How do you ensure the integrity and security of components? You can also use it to log vehicle performance data on a blockchain to prevent fraud. This is of interest to people like insurers and law enforcement. Also enable pooling data from vehicle owners, fleet managers and manufacturers to shorten the time of achieving safety and security for autonomous vehicles. Now, what that means is we've been thinking pretty much most of the time, we've been thinking in terms of a single car, because that's not too difficult to get your head around. Trying to get your head around thousands of cars or millions of cars, that's a lot different. But if you could pull all that data anonymously about the performance of these cars and kind of incidents they might be involved in, and you could put that on a blockchain and make that open for mining, then you get some really interesting insights. And the theory is that it will speed up the development of autonomous vehicles. That's the theory. None of these are actually real yet. These are just ideas, but we might see them. But certainly you will see blockchain starting to appear in the automotive sector. And of course, some big players in here like IBM. Okay. Conclusions. What have we learned today? Well, we are heading for a driverless future, but I think public acceptance is absolutely critical. That poll showed earlier. There are a myriad of ways you can hack into cars because they've got a very large attack surface. And if you think about creating, a whole kind of infrastructure of connected cars, then, well, it's kind of exponential. Potential threats you can get. It's early days yet. It's kind of like you can think of it almost like an arms race that you'll see over the next 10 years or so. So the vendors will try and nail down their security on the cars, and the hackers in turn will also be on a learning curve. Okay, so you're going to see something almost like an arms race. Number 3, as I mentioned, the automotive sector has developed an exemplary safety culture, but they've got a lot of learning to do before they can integrate that with a security culture. And this is what the new actors in the space are kind of bringing into it. Existing processes and technical standards, as I explained, they are inadequate, but there are many new initiatives. So people know what needs to be fixed. It's just time and effort to fix them. And 6, I think we're witnessing the birth of what I call the infomotive industry. But cybersecurity, unfortunately, lags somewhat behind. Okay. Okay. Right. Okay. Let's revisit our poll again. Let's go back to this proposition. Has anybody changed their mind as a result? No? Nobody changed their mind? All right, okay. You've changed your mind. Why have you changed your mind?
Yes, I don't think I would trust. I thought progress was quite good, but as you say, the attack surface is very more too early to trust.
Yes. Oh, microphone.
I am amazed you said that, the figure's not right, but the planes are 5 million lines of code, and cars got 150. That's just crap software. I can't believe that a plane is more complicated than.
This is one of the.
Not on that kind of scale.
Yeah, this is one of.
And you cannot have a reliable system that I would trust that amount of software.
Yeah, and it's more complicated. Again, going back to the long supply chain, and they're all producing their own software. Now, things like AutoSAR, where you're having portable modules, will help, okay, over time. But again, a lot of this stuff, the thing about cars is a lot of the stuff you don't actually need. Okay, right? It's just multimedia stuff. It's not like a plane where you definitely need code to stay in the air. But the cars they pack in, they're consumer goods, which jumbo jets aren't. So they pack in a lot of code. And as you say, there is a lot of research going into improving software quality, trying to get down to maybe 5 bugs per 1,000 lines of code or something like that. That would be typical for something like aerospace, 5 bugs per 1,000 lines of code. But not there yet. But what they really need to do is to get kind of aviation standards of safety and security into what is essentially a consumer product. That involves a cost. So are people willing to pay for these things? Time will tell. Yeah.
Thank you for the talk. Yesterday I was in Waterloo to a philosophical meeting. The question asked was, what coding or code are you going to use to tell the car which people to kill?
Yes.
Because there will be situations where a decision has to be made as to who you're going to bump into. The trolley problem.
That's what they call the trolley problem. It's a well-established problem, or there's various, the dog and child problem, where the dog runs in front of the road, child runs after it. Which do you run over? Or do you swerve off the curb and mow down people at the bus stop? Yeah, there's variants of that. There's no easy answer to that. That's ultimately a question of ethics. I think what's missing from the government's discussion about this is any suggestion of ethics. There's a lot of this going on. Google Car, or Waymo as now, does have a very secretive ethics committee. They never publish their findings, but they are taking this seriously. So, and also the German government a few years ago, I think it was Daimler or Mercedes, or was it BMW? They actually held an ethics conference. It was the very first ethics conference organised by the automotive industry. And now the German government, or one of the federal states, has now actually got a kind of formal initiative on ethics. So the industry is taking it seriously. But you've got to involve people like insurance companies, lawyers, and security professionals. There's a lot of people who need to come to the party to decide that one. It's tricky. Oh, one interesting idea I came across was that, no, 2 interesting ideas. One was, well, if you got in a completely driverless car, you could turn a knob to select it yourself. So do you drive straight on, or do you drive left up the curb, or what do you do? That's one way of resolving it. Hand the decision not to the coders, but to the person who's using the vehicle. But, silly idea, but interesting.
Thanks very much for the presentation. I really enjoyed it. But all the stuff you've been talking about was covered 60 years ago by a science fiction writer named Isaac Asimov.
Oh yeah,
Who
yeah.
wrote about his autotronic cars.
Yes,
Which actually then eventually led to the people robotics.
yes.
Now, all the issues, both practical and moral, that are being raised, I think the various governments and the car manufacturers should go back and read Asimov's books.
Yeah,
He
absolutely.
covered all these things in great depth.
Mm.
And the cars he was talking about were more advanced than the Tesla. They were fully autonomous vehicles. Every one of his books or stories about these cars was really relating to both the moral and the practical.
Yes, absolutely. Yeah, yeah. Essentially, what we're heading for is robots on wheels. Right? So that's essentially what we're heading for: robots on wheels. And you can see that. I mentioned Tesla earlier and GPUs. Yeah, well, they're finding, generally speaking, stuff you find in the data center today, like GPUs, FPGAs in some circumstances, automotive grade Linux, Zen server for hypervisors, all that stuff from the data center might find its way into your car. Okay? So this enables a lot of ever more powerful applications. So you see more kind of AI and deep learning in high-end cars.
We've got 10 minutes for
Yes.
questions. Can I just remind everyone, please sign attendance for the sign. Please sign it after this. Thank you.
Thank you. Thanks very much for the talk. So it seemed from one of your later slides that the automotive industry itself are starting to kind of talk to one another, and they're talking to technology companies as well. So, I'm new to the subject, but it would seem to me that the aviation industry has actually been dealing with, the concept of automation in practice for many, many, many years.
Absolutely.
And I'm sure that they're dealing with issues around security and connectivity as well. So how are they being consulted on these issues? Because it seems there's a bit of information already there, obviously, of its differences in the industries. Even so.
Yeah, they do have some commonality. For example, I mentioned like CAN bus, despite its kind of security flaws, that's used quite widely in the aviation industry. But you're not quite likely to get hackers in the sky, as I'll say. So I'm sure if you start reading about the kind of safety and security things, there are often references to comparisons to the aviation industry, and that's the kind of standards they need to get to. But the question is, at what cost will people pay for that? I mean, the prevailing wisdom for a long time in the automotive industry is that adding security features provides no return on investment, which it doesn't until you have some nasty incident.
Following on this topic of the aviation industry, I'm pretty sure I saw a case study that said someone managed to hack a plane via the infotainment system.
Yes. Yes.
So that's kind of similar to the cheat story.
Yeah.
The other thing in response to the gentleman at the front was asking about the kind of comparative difference between 5 million lines of code in a plane and 150 in a car. But actually, think about it. The plane, the context the plane operates in is probably simpler than an urban environment.
Oh, it is. Absolutely, it is.
Yeah.
Yes.
So there's a massive amount of complexity and
Yes.
that's just kind of behaviour that's going to have to be designed for. Which I think is going to be a big problem for many, many years, particularly what you were saying around the different types of vehicle. How is an autonomous vehicle going to deal with a manually driven car? Exactly. They start using the fact that an automated car will stop if you do something silly, whereas a human will abuse that situation.
The case of manually driven cars interacting, people interacting with autonomous cars is quite interesting. For example, Google car, they found that the car behaves rationally, which is to say, it comes up to a junction, it stops, it waits until there's a decent gap in the traffic, and then it pulls out. But in the meantime, you've got people around there honking their horns, who would have just put their foot on the gas and gone out there. So people have been cutting up Google costs. This is another area of research that a lot of people are looking into, user experience, especially that kind of thing.
It's the follow-up one, if you don't mind. I'm a big cyclist, and
I imagine, brilliant.
and I've read mixed things about how well autonomous vehicles will work with,
Yes.
with cyclists. It's interesting to see all vehicle to person. That's the first time I've seen that sort of raised around.
Vehicle to horse.
Yeah, I mean, maybe Garmin cycling into a future will have something in it
Yes.
that alerts you to kind of an autonomous electric vehicle. That's really, really interesting. So that's the first time I've seen that kind of problem addressed. But what else have you kind of, where is your head on, cyclists being detected by automated vehicles? Do you think that's a solved problem, or do you think it's still a grey area?
I think it's not a priority. The automotive industry. I think cycling groups are sort of talking about it, but they don't really have a voice in this at the moment. I think you need to get a few cyclists. I hate to say that, but it's probably true. One other wacky idea I came across a little while ago was the idea that these cars would be so reliable, they would never collide. So the bodywork for these cars could be as thin as an eggshell. Do you buy that idea? I don't. Do you? Possible.
That was retrievable.
Well, yeah, absolutely.
Well, it's a cyclist, is it?
Yes. Yes. Yeah, so that's interesting. I'm trying to look. Any more questions?
Any more questions? The last question.
Do you think there'll be generations of cars becoming automated, so that motorways will become effectively driverless cars to start with, because we can just ban all cars from the motorway and they all have to be automated, in 10, 15. Whereas I personally would be happy not to drive a motorway and dual carriageways, but on country roads, I want to be able to stay driving because I enjoy driving those country roads.
Yeah.
Do you consider that there will be a time when people won't be able to drive?
Platooning, you talk about, like these trials, they're doing it with trucks, and they've done it with cars in some countries. But I think you will get to a point where you could see platooning for maybe groups of cars, and maybe they won't be, instead of being widely spaced together, the problem with all these kind of traffic flows is that at the moment they're dependent on the reactions of the driver. Okay, but if you can regulate that, then in theory you can bunch them all together, and there's various. I don't know. It's your answer to that one. There's different schools of thought on that, whether that's beneficial or not. Some people say it's environmentally beneficial. So
people think that people will be banned from driving on the motorway, really, because it's a closed environment. Really.
At some point, I could see any kind of manual cars probably wouldn't be allowed on motorways. Same with trucks. But I think at least 20 years away. Yeah. Right. Yeah.
Okay, thank you very much, everyone.
Okay.
Thank you, Bill. That was very interesting.
One final thing is automotive cybersecurity meetup. If anyone's interested in getting them off the ground, come see me. Break. They exist in some countries like Netherlands, Germany, but none in the UK yet. London would be a good place to start on. But if you're interested in helping this automotive cybersecurity meetup, that'd be very interesting. We get to meet lots of interesting people like me and others and so on. Okay, whack me if you can.
I think a sandwich and drink, wine is outside, so please help yourself.